the science guy. Bill Nye, the science guy.
Welcome to the world of gases! Gas behavior and gas reactions are part of everyday life. Studies are done on gases to understand how it reacts, thus preventing future damages to the environment and leads to an advance in gas-related technology. Gases are crucial in different areas, from medical technology to food industries. For example, Coke, which is a carbonated drink. Next is plants, which perform photosynthesis. Photosynthesis is a reaction which uses carbon dioxide gas along with other reactants and produce oxygen gas, O2, which we need to breathe. Okay. And high in atmosphere, ozone gas interacts with dangerous ultraviolet light to protect us from sun's harsh rays.
Hey, we're here for our Kuwait Cool Sciences interview with Mr. Roach. So tell us about yourself, Mr. Roach.
Well, I'm, as you know, I'm a teacher at Georges Henry Academy, but before I was a teacher, I used to work as a field biologist and an environmental scientist for consulting engineering companies here in Ontario. So I used to do environmental field sampling, actually doing water quality testing and sampling of, or looking at different animals that lived in different environments and plants and vegetation and all sorts of things like that as part of reports for government, mostly.
Cool.
Yeah, and then I got into, so I always liked science, and then from when I was in high school and university and all that kind of stuff, and then made it a career for a while, and now I'm in teaching science.
Awesome.
Sometimes, so yeah.
So, can you tell us a little bit about gases?
Gases. Well, I can tell you that a gas is a state of matter where the gas, it's kind of different than what you see with liquids and solids because gases have no defined volume and no defined sort of shape. They sort of fill whatever the container size, the shape of the container is whatever they end up, and that becomes their volume, and that also becomes their shape. And if you change the shape, then you get a different, change the container, you change the shape.
Okay, so the container is how you measure the gas volume.
Yeah. In a sense, that's definitely how you measure the volume of the gas. Yeah. So, I mean, there's more to that, to measuring volume, but that is generally how you look at gases. Aren't sort of constrained by, because they will expand to fill whatever container they happen to be in.
So how does gas particles behave?
You have to go back to the kinetic molecular theory, if I remember my gas stuff correctly, where gases basically move around. They're far apart from each other, and they have lots of energy, and so they're constantly moving and bumping into each other, and as they move around, in that bumping process, they end up filling the space in which they're contained. So again, filling the container.
So, what kind of gases can we find at room temperature?
Room temperature, we have nitrogen, we have oxygen, we have neon, we've got, carbon dioxide, carbon monoxide, which is the bad one, helium, hydrogen.
So what kinds of gases is our atmosphere consist of, mostly?
The atmosphere is mostly nitrogen. 78%, I believe, is nitrogen. And then you've got about 21% oxygen. And then you have trace gases, argon, carbon dioxide, water vapor, and there's even ones that go smaller than that. But the vast majority of the atmosphere is nitrogen.
So we breathe in most of nitrogen.
But it doesn't. It's because it's molecular nitrogen. It's N2. It doesn't interact with our bodies. We just breathe it in and breathe it out. It doesn't go anywhere. Whereas the oxygen does do something. It's actually broken down and used in the body through respiration. But the nitrogen, yeah, we breathe in a lot of nitrogen, but it just doesn't do anything for us.
Okay.
Yeah.
Thank you.
So that's it?
Yeah.
All right.
Thank you so
Thank
much,
you.
Mr. Roach. How I behave in a fixed container. Whoa! 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 So I take up a lot of space and move around in a straight line. Usually when there's another gas particle, I usually collide with it and then bounce back. And that's how I behave in a container.
Consider the following. According to a study, natural gas is a product of decomposed organic matter. It is a byproduct of plants and animals that are decomposed without the presence of oxygen. Also, natural gas in the future may be produced by biomass, which can be animal waste, sewage, or trash.
Hi, I'm Jim, and I'll be doing an experiment with you today. For the experiment, you'll need a 1 or 2 liter bottle, a round balloon, and pointed scissors. The first procedure is to take the ends of the balloon and put it over the top of the bottle. Like this. 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 Yeah, gee. And then you'll inflate the balloon as you stretch this over your hands. Cut a hole in the bottom, inflate the balloon, and record your observations. That's the end of the experiment. This experiment shows that gas has volume. Also, it shows that gas molecules have high transitional energy and they move randomly in straight lines.
Now we have Boyle's law.
Yeah, Boyle's! P1 equals to P2, yeah!
His law states that the volume of a given amount of gas at a constant temperature varies inversely with the applied pressure. In other words, as the external pressure of a gas increases, the volume of the gas decreases.
That is V1 over T1 equals V2 over T2.
His law states that the volume of a fixed mass or gas is proportional to its temperature when the pressure is kept constant.
Hi, I'm gay. Blue sack. No homo. My formula is P1 over T1 equals P2 over T2.
His law states that the pressure of a fixed amount of gas at constant volume is directly proportional to its Kelvin temperature.
Boyle's
Charles.
Gay.
Creates combined gas law. The formula is P1 V1 over T1 equals P2 V2 over T2.
A combination of Boyle's law and Charles' law, which states that the pressure and the volume of a given amount of gas are inversely proportional and directly proportional to the Kelvin temperature of the gas.
The gases, it's close to Camp Town, and all sorts of gases are floating in the air. It is matter, made of particles that are everywhere. You try to bond, but the chlorine took the oxygens apart. Because the pollutant that breaks the ozone in the atmosphere. Stop the planes, cause this is gases, and only we can save us from the gas around. You know they're gases. The environment's getting damaged every day. Gases,
Now that you know how gases behave, its properties, and how the particles move, you know that the particles inside these balloons are colliding with each other as we speak.
Now that you have watched this video, you have got lots of good information about gases, which you can use in your daily lives. Thanks for watching Bill Nye the Science Guy.
Bill Nye the Science Guy.